What determines the chemical properties of a molecule in organic chemistry? Well, it's somewhere between the functional group and the homologous series. Homologous series doesn't decide exactly how reactive it is. It's actually, or what type of reaction it will undergo. It's actually the functional group that dictates that. The condensed structure of a formula of an organic compound is shown below, and we can sit here and we can make a chain, and we see that it is a chain of 8, and then we need to say, are there double bonds anywhere? No, there aren't, so it's going to be octane probably, and then there's this bromine hanging off and this bromine hanging off. So we're going to label these from this side because it's closer to the first bromine. 1, 2, 3, 4, 5, 6, 7, 8, and we land up with 3,5-dibromo-octane. Which of the following pairs of compounds correctly represents the products formed during the complete combustion of anything? In this case it is octane, and it's going to be your carbon dioxide and water are your products of a combustion reaction. When a chemical reaction is exothermic, we will have the products having, let's just draw a quick little exothermic graph. So the products have clearly got less energy than the reactants. More heat energy is absorbed than released. No, it's exactly the opposite way around. Delta H is negative on exothermic. The products have less potential energy than the reactants, yes. The products have more potential energy than the reactants, no. So C is your correct answer. Nitrile chloride is able to thermally decompose according to the following equation. If the activation energy for the forward reaction is 100 kilojoules, so let's draw ourselves a little diagram here as well. It's an endothermic reaction this time, and we have been told that this is 100, and we have been told that this is 34. That would obviously mean that the activation energy for the reverse reaction, which is this over here, is going to be 100 minus 34, and you land up with 66 kilojoules. Consider the equilibrium reaction represented below. Unfortunately, this particular example isn't really in the curriculum. You were expected to know that if you added silver nitrate to the solution, you would use up, it would react with the the chloride ion, and therefore that would land up favoring the reverse reaction, because this would disappear and the system would try to make some more of it, and therefore it would turn from blue to pink. But it's not in the curriculum because silver nitrate's reaction with chloride is no longer in the curriculum, so that was that question was scrapped. Consider the following equilibrium system. Now, we're going to be asked some questions about pressure and about temperature. Delta H is less than 0, so this is an exothermic reaction. Which of the following graphs correctly shows the effect of temperature and pressure on the percentage of ammonia, in other words, on the yield of ammonia? So if it's an exothermic reaction, we are going to want to make it as cold as possible. And therefore, as the temperature increases, as we go along that way, we will find that theoretically my percentage yield should land up decreasing as I get hotter and hotter and hotter. So that means that it's either C or D. Then we need to consider that we have got 4 gas moles on the left and 2 gas moles on the right. So what's going to cause the highest yield of ammonia is going to be high pressure. So you land up with the high pressure giving you a higher yield. So high pressure gives a higher percentage, and that makes sense. So D is your correct answer. So you have to consider both of those. 64 grams of sulfur undergoes complete combustion in excess oxygen according to the following equation. What volume of sulfur dioxide gas at STP would be in decimeters cubed would be produced by this reaction? So the first thing is we need to work out sulfur. 64 mass over molar mass of sulfur is 32, so that's 2 moles. The good news is this is a 1-to-1 ratio, so that means that there's 2 moles of SO2, and now they're asking me for volume, so it's 2 times 22,4, and that means it's 48,8 decimeters cubed. According to Lowry-Bronsted model, all bases are proton acceptors, pure bookwork. Which statement is incorrect? A concentrated acid can be weak. That's true. A strong acid can be weak. No, either acid is strong or it is weak. If it's dilute, it can be strong, yes, and if it's concentrated, it might be strong. So you can have concentrated or dilute with strong or weak, but you cannot have strong with weak and at the same time, and you can't have concentrated and dilute at the same time. So B is your correct answer.